Now remember, when we add or subtract fractions, the denominators must be the same in order to add the fractions. Now if the denominators are not the same, then we need to get them to be the same using a least common denominator. We also call that the LCD for short. So first, let's take a couple minutes to find out how to find the least common denominator. So we're just trying to find them, then we will use them in a little bit. So the first step of finding an LCD is to factor each denominator. I want you to write down one of every kind of factor and then raise each factor to its greatest power. So we're going to use this process to find the LCD for the following problems. 5 6 plus 11 eighths. Now some of you might be able to look at 6 and 8 and just come up with an LCD in your head because you've done this for quite some time. But I'd prefer if you tried to use our method so that we can take something simple like the LCD between two numbers and apply that to the LCD of polynomials. So when we take the factors of 6, that is 2 times 3, and then the factors of 8, which is 4 times 2, and then that breaks down to 2 times 2 times 2. So 6 can be rewritten as 2 times 3, and 8 can be rewritten as 2 cubed. The LCD tells us to write down one of every kind of factor, so that's every unique base. So 2 is a factor of 6, and 3 is a factor of 6. 2 is a factor of 8 3 times over, right? So we have all of the unique bases, 2 and 3. Then raise each factor to its greatest power. So the greatest power of the factor 2 is a third power. So now that's got everything covered. The 6 demands that we have a 2 and a 3. In our LCD, do we have a 2 and a 3? Well, sure we do. The 8 demands that my LCD have at least 3 2's. Does it have at least 3 2's? Well, sure it does. So this is the least common denominator. It's the least number that satisfies all of the requirements for 6 and 8. When I multiply this together, 2 times 2 times 2 is 8, and 8 times 3 is 24. So my LCD is 24. Now some of you might have been able to figure that out just in your head, knowing that 24 is the smallest number that divides evenly into 6 and also divides evenly into 8. But we're trying to show you how to apply this to other numbers. Now on the next problem, a squared b cubed c and a b to the fourth c to the fifth d, all of those are already factored out, okay? Like on 6, we had to break that down to 2 times 3, but there's nothing else we can break down here. So my LCD is going to be one of each factor, A, B, C, and D. That's step 2 because there is no factoring to be done in step 1. Step 3 says raise each factor to its greatest power. So for the A's, between the two A's, what is the greatest exponent or power? Well, in that case, it's squared. Okay, so then let's look at b. b cubed and b to the fourth. Which one has the greatest power? Well, that's 4. So b to the fourth is my LCD. In my LCD. c and c to the fifth, which one has the greatest power? Well, that's 5. And the last one is d. Now, this one doesn't have another factor on the other side, so the lowest power is whatever the one factor is, and that's d to the 1, and I don't really need to write that. So a squared, b to the fourth, c to the fifth, d is my least common denominator. That one I think was a little bit easier because you didn't have to factor anything out. If you go back and make sure each denominator is within the LCD, then we can double check. So the first denominator says you have to have at least 2 A's. Check, I have at least 2 A's. It says I have to have at least 3 B's. Yep, I have 3 B's and more. And then we have to have a C, and we have at least 1 C and more. On the second denominator, I have to have at least an a. Yep, got it. I have to have at least 4 b's. Yep. I have to have at least 5 c's. Yep. And I have to have at least 1 d. And that's the lowest number that can satisfy both little denominators. Now on the third one, it doesn't look quite like the other two at all. But remember what the first step said. Factor each denominator. If the denominators were just numbers like the first one, factoring the 6 and the 8, that wasn't hard at all. We just broke it up into its factor trees. These are polynomials, but we can still factor them. The first one factors into x plus 4, x minus 1. And the second one factors into x minus 5 and x plus 4. The second step says write down one of every kind of factor. So I have an x plus 4 factor, I have to have an x minus 1 factor, and I have to have an x minus 5 factor. Those are all of the unique factors. The third step says to raise each factor to its greatest power. So between x plus 4, now there's two x plus 4s, but the greatest power of the first one is 1, the greatest power of the second one is 1, so the greatest power of either of them is 1. Or really, do you really need to write 1? Probably not. The greatest power of x minus 1, that's 1, and the greatest power of x minus 5, well, that's just 1 as well. To go back and check, the first denominator required at least 1 x minus 4. Does it have it? Yes. It required at least 1 x minus 1. Does it have it? Yes. The second fraction did not require at least 1 x minus 5 and at least 1 x plus 4, and I have it. So this is how you find the LCD. Okay, adding and subtracting rational expressions with unlike denominators. The first thing you want to do is to find the LCD, which we just showed you how to do. Then you need to rewrite each fraction with the LCD by multiplying the numerator and the denominator by any missing factors that you don't already have in the LCD. So then we need to combine like terms in the numerators and reduce if necessary. So let's go back to adding 5 6 plus 11 eighths. So I just want you to be able to add these two very simple fractions before we get to the polynomials. So we said earlier when we were finding LCDs that the least common denominator was 24. So I'm not going to go through that process again. This is the same problem we just had above. So step 1, find the LCD. Step 2 is rewrite each fraction with the LCD by multiplying the numerator and the denominator by any missing factors. So 6 was the factor I had, and I need to get up to 24. So what factor am I missing? Well, I'm missing a times by 4. 4 times 6 truly is 24. So I'm going to multiply the denominator by 4 to make it into my LCD denominator. But I can't just multiply the denominator because I want to, but I also have to then multiply the numerator. It says you have to multiply both the numerator and the denominator by missing factors. So that gets me 20 24ths. Please do not reduce this. If you reduce this, you know what's going to happen? You're going to get back to the original problem, and that's really not going to help you get anywhere. On the second fraction, I have an 8. I would like this 8 to become a 24. So what is the factor that I'm missing to make 8 into a 24? Well, that factor is 3. So I'm going to multiply the denominator by 3 because 8 times 3 truly is 24. And then if I do to the bottom, you have to also do to the top. And that gets me 11 times 3 or 33. When I add my numerators now, I'm getting 53 over 24. And 53 24ths does not reduce, so I am done. So let's try our next problems with polynomials. The first step said to find the LCD. So the first fraction is x to the 3, the second one is 8 times x. So in each of the two denominators, I have two different bases. I have the base of 8 and I have a base of x. And the highest exponent of 8, well, that's just 1. The highest exponent between the two x bases is 3. So my LCD is going to be 8x cubed. All right, to get my original x cubed denominator to be 8x cubed, what is the factor that I'm missing? Well, I'm missing a copy of 8. So if I multiply the denominator by 8, you also must then multiply your numerator by 8. All right, in 8x, I would like it to be 8x cubed. So I have an 8x, and I need it to be an 8x cubed. In order for 8x to be an 8x cubed, it needs more x's. Well, that's 2 x's. Okay, now that's a total of 3 x's, right? So 8x cubed is really 8x times 2 more x's. So the missing factor here is 2 more x's, or x squared. So 8x times x squared truly is 8x cubed. If you multiply it to the bottom, you have to also then multiply it to the top. The third step says combine like terms in the numerator. Now that you've got the denominators the same, we can keep them the same. And then in the numerator, I have 40 minus x squared. Now 40 minus x squared does not factor. It kind of looks like a difference of 2 squares, but 40 is not a perfect square, so this can't go any further, and I am done. On our next problem, we look at the denominators first. The denominators are not the same, which means I have to find an LCD. The LCD says take one of each factor, so x minus 1 is its own factor, and I have to write it at least once, and then x plus 4 is its own factor. So these are the two copies. Each of those have an exponent of 1, so when finding the LCD, I need to raise each factor to its greatest power, but the greatest power is just 1. So I have found my LCD. All right, the next step is to multiply the numerator and denominator by any missing factors. I have an x minus 1 in the first denominator. I need an x minus 1 times an x plus 4. What is the missing factor? Well, the missing factor here is x plus 4. If you multiply it to the bottom, you also then have to multiply it to the top. Now, I'm not going to multiply this out just yet. I'm just going to write it here for one step, and I highly suggest you do the same thing, especially when it's a subtract problem, because you might have to distribute a negative. So I just practice, don't distribute this out until the next step, and hopefully that'll help you. On the second fraction, we have an x plus 4, and I need an x minus 1, x plus 4. The missing factor there is x minus 1. If you multiply it to the bottom, you need to multiply it to the top. So now that the two denominators are the same, I can distribute my numerators. I'm going to write this one more time as a fraction here so that I remember that the plus goes with the 6 when I distribute, which gets me 3x plus 12 plus 6x minus 6 all over that same denominator. And then I can combine like terms in the numerator, 9x plus 6. It looks like that numerator can factor, which gets me 3 times the quantity 3x plus 2. That doesn't divide out, so that's my final answer, which means that because nothing divided out, either one of these would have been okay. If you didn't factor, you got lucky this time. But if you did factor and something divided out, well, then you really need to do it, otherwise you'll lose some points there. So in this case, either one will work.